Welcome back. Are we all full of energy? Are we all full of energy? I'll take that as a yes. Right, great. Next, Adam Harvey is going to talk about quantifying Nebraska. Please welcome Adam.
Thank you very much. Good afternoon. I can't see you. It's pretty dark there, so if anybody naps, I really won't be terribly offended. Speaking of napping, I'm Adam. That's my napping collaborator, Stanley. He's an expert. In the past, I've contributed to PHP, worked at New Relic on runtime language instrumentation, accidentally got a film degree, and today I work at the Rust Foundation on ecosystem security with a special focus around supply chain security, which in practice means I write code to try and find people who are trying to steal people's Bitcoin wallets in crates. I'm also a member of the Rust project's crates.io team. Crates.io is the Rust version of PyPI. This talk is kind of related to that work and also kind of not. We'll see where we get to. I was just saying to Nick a year ago, not many people were putting this comic in slides, and then I went to a conference where literally everybody did, so I apologize. But we all know this, right? Like, there are everything that we build, generally speaking, in Python and most languages now depends on lots of other things. Often, sometimes directly, often transitively. Most of you have probably heard this story already, but I know there's always a few people who haven't, so I'm going to summarize this as quickly as I can. If you already know what happened here, feel free to look at your phone for the next couple of minutes. I won't be offended. So XZ, obviously I'm going to pronounce this the correct way, is a compression standard like gzip, Z standard, and various others you've heard of that has been in widespread use for several years. The core of it is an open source project called xzutils that provides a C library to handle compression and decompression. Python actually includes this in its standard library via the LZMA module. That's been in there since Python 3.3, which I was horrified to realize this morning it was over 12 years ago. So it's been in there for quite a while. For most of its history, xzutils was a one-man project written and maintained by Lasse Collin. Like a lot of open source maintainers, the amount of time he's been able to devote has sort of waxed and waned over the years. And a couple of years ago, he got some not super friendly mailing list posts insinuating that he wasn't doing a good enough job of triaging bugs or responding to feature requests. So for example, the last couple of lines, I won't read the whole thing, but the last couple of lines of this message on the XZ development mailing list were, "You ignore the many patches bit rotting away in this mailing list. Right now you choke your repo. Why wait until 5.4.0 to change maintainer? Why delay what your repo needs?" So, super friendly. I want to be clear, this also appears to have just been not true. Xzutils seem to be doing just fine because it was a mature thing and just wasn't moving that fast. But this factors into something that I feel like every open source project maintainer feels, which is that you always feel some level of internalized guilt about not being able to do more. Even if you're spending ridiculous amounts of time on it, you still feel guilt about not being able to do more, because there's always more to do. Around the same time, a new contributor popped up called Giatan. Gia provided several bug fixes and was apparently very helpful as a sounding board and contributor. And most importantly, they didn't just drive-by contribute, right? They didn't just send 1 or 2 PRs and then move on. But they stuck around, and eventually Lasse Collin promoted Gia to co-maintainer status, and Gia released version 5.6.0 of xzutils in February last year. It was actually about a year ago. Anyway, that release included a backdoor. Most of that backdoor was not in the Git repository for xzutils, but it was only in the actual tarballs that got released, the actual release artifacts. So in Python terms, they were in the wheels, but not in the source code in Git. And aside, tarballs not matching their upstream repos is really depressingly common in the C world because usually you pre-generate bits of the build system so that users don't get exposed to the full horror of GNU auto tools and other such build systems. An aside on the aside, after this, I and lots of others did work on various ecosystems to figure out, were there things that didn't match their upstreams? This is my tool for Rust. There is an equivalent for PyPI. People are looking into this now. It was always kind of a known theoretical thing, but it was never seen as, the lowest hanging fruit. The exact details of what the backdoor would have done don't really matter. It was just say it was really bad. Like, your system would have been, in theory, owned. But the good news is it was implemented really badly. It didn't actually work properly, and it caused a memory leak that was spotted by a guy called Andres Freund, who was doing unrelated testing work on PostgreSQL, which uses xz transitively, a few weeks later, critically before most distributions had updated. So, cool, we dodged a bullet. We got super lucky. This is great. We actually got unbelievably lucky. Like, this is the kind of thing, like, people don't generally, maybe a few big companies, but people don't generally review every line in like every diff between versions of every dependency, right? Like, again, there's only so many hours in people's lives. So sure, open source, many eyes, bugs are shallow, all those, platitudes, but I don't think this would have been caught anywhere near as quickly had it been implemented competently. So thanks whichever security service that was for messing that up. Okay, so that's the background. But there are two aspects of this that I think were interesting from a security perspective. The first was the way it was sort of hidden, right? Like I said, this was hidden in the release artifacts, but not in the actual Git repo. For the most part, there was a little bit that was in the Git repo. It doesn't really matter. Someone who was reviewing the changes between versions in GitHub or in this case GitHub, but whatever forge they're using, it's really common for people to just look at those diffs because it's much nicer than running like diff-ur, capital N, old version, new version in the tarballs on the command line and reviewing it there. So a sloppy reviewer probably would have missed this, right? And I'm not going to say that all reviewers are sloppy, but that they're often time poor, right? Like I am. So it could have been missed because there was only one specific change in Git, which was, I have on screen, which was disabling the Linux landlock access control mechanism. And if I had my pointer, which sadly I found out today is no longer working, that little full stop at the bottom left was the only thing that actually broke it. Feel free, I'm happy to explain that later. I'm not going to do it on stage now. But the second thing that was really interesting here was this wasn't a case where a maintainer had their credentials popped or where there was impersonation going on, or basically all the things that everybody I know who was working in supply chain security had basically spent the previous 5 to 10 years worrying about. Like, this was a case where the call was coming from inside the house. Like, the thing I keep coming back to on this is it's not really about the security angle. It's kind of where this took place and how. If you'd asked me this time last year what xz was, I think I probably would have gotten as far as saying, I think that's the compression standard used for Arch Linux packages, which I actually don't think is true anymore, but I think it was a year ago. I certainly didn't know who maintained it. I'd never heard of any of these people. It was one of those libraries that gets installed on your system, you never think about again, it just kind of sits there and works, right? Like I said, in Python, there's no xz package to pull in, at least in the standard library, or xz module. It comes in transitively through LZMA. So how much awareness was there of xz? I don't know, not very much. And I'd actually like to think I mostly pay attention to this stuff. Maybe I'm just giving myself too much credit, but I don't know. It seemed, as I said, unexpected. So it's a thing I've implicitly depended upon. Every Docker image I've probably built for the last 10 years, Docker hasn't been around quite that long, probably includes xz somewhere in there. But I've never thought about it. So it was literal, metaphorical Nebraska. So like most of you, I want things to be stable, secure. Some dependencies are stable because they just never change, but that's pretty rare. Like, even xz, even though the format's been stable for 15 years or whatever it is, there were still regular releases, right? Platforms change, CPU architectures have weird bugs, all that kind of stuff. So how do we not have another of these happen, basically? So my contention, which I don't think is controversial, is that code and things in really anything is generally going to be better, more stable, more secure if it's properly supported, which kind of gets us into like Maslow territory, right? Like, in a perfect world, I don't want open source maintainers having to worry more about housing or food as their primary concern. And that's before we even touch on like politics, geopolitics, etc., which I'm not going anywhere near right now. So that's kind of the rub. If you don't know what you're relying on, or you have like just really low levels of ambient awareness about them, you can't really know whether these projects are doing okay, right? Like, are there people writing angry mailing list posts about the project not being supported, not being maintained, releases not happening? More importantly, can we use what we already have, the tooling we have, to try and find projects that maybe we can help with, maybe we can support, maybe try and find the ones that need that little bit of a helping hand. So I'm going to run through just a really rough example and sort of like mostly just talk about how I personally think about this, and I hope this is helpful in terms of framing for how you all can think about this. I'm obviously going to use a Python example because, it's a Python conference. We're also going to do some hand waving because it's a 25-minute talk and I'm already 10 minutes into it, and there are limits to how far I can get into this. But nothing I talk about here is exclusive to Python in particular or any one ecosystem. Like, this exists in pretty much any modern programming language that you're probably going to use. Like, I'm going to bet most of us at least occasionally have to write code in JavaScript or your favorite thing that compiles down to JavaScript, right? So there's another ecosystem right away. Okay, so I'm going to use Zulip as an example, which is a project that's best described as a fully open source Slack alternative. We use it in the Rust project as our primary chat and collaboration platform. Conveniently, it's written in Python and it uses Django. So nothing wrong with Zulip. It's just a good example to like dig in from here. Like most Python projects, we have requirements files in the repo. They're actually locked, which is nice, so good job. And of course, it's one of those things where, like I said, usually when I'm working on a project, I'm sure this is true for all of you, like, I know what I'm working with, but I probably don't know what they're depending on, right? Like, I don't know what AIO Happy Eyeballs does, for example. Sounds fun. So it's built on top of it's built on top of Django, which means, it's using Django. Django depends on these things, actually depends on more than that, but this is what deps.dev gave me this morning, and I didn't really want to investigate why it was only giving me a handful of dependencies, but it actually makes for a better example. So we're implicitly also having to trust and rely on SQL parse, asgref, typing extensions, and then obviously that just continues, right? Like, for example, Zulip uses the Django auth LDAP modules to provide LDAP support. So all of a sudden you've got a bunch more things that come in, Python LDAP, PyASN1 modules, etc. So I used a tool called Sift to generate an SBOM. Some of you may have heard of SBOMs, a software bill of materials from that requirements file. Technically, actually, I did it from the Docker image just because that was easier, but you can do it either way. What that gets us is a list of every dependency, transitive or direct, that is dependent upon by Zulip. There are 592 unique Python dependencies in there. Also 420 node dependencies, 261 Go dependencies, a bunch of Debian packages, because it's a Docker image, and so on. So we can use this data, particularly, I find the package URL, which is the first sort of green line in there, to get other metadata that we're interested in evaluating the health of projects, right? How they're doing, how sustainable they are. But here's the thing, like, I probably can't go look at 592 unique Python dependencies, right? Like, even if some of them are in the same repos, it's presumably 300 plus repos. I don't have the time, the resources, the energy, particularly at 4 o'clock on a Saturday after snacks, to go look at this. I can look at a few, but I can't look at that many. And of course, just to be clear, this is still incomplete, right? Like, Sift doesn't go down into the next level of like C or Rust dependencies. Like, if you're using cryptography, then there's a set of Rust dependencies. If you're using pretty much any module that wraps a C library, obviously there's other stuff. There are limits to how deep you can go. We probably can't do much to directly find or help the sustainability of the people in Taiwan working at the chip fab, but you should probably try and go one layer deeper than you think. So how do we evaluate these? So this is a screenshot of a landing page for something called the OpenSSF scorecard. OpenSSF is a Linux Foundation working group, I think. Please don't quote me on that. That does basically supply chain security stuff. They try to capture various metrics and quantify them. They actually don't publish them on their website, but Google's open source office runs this thing called deps.dev, which does actually show this. This is a well-known Python package, I won't say which one, that basically tries to score these things on, various best practices. It's a little small. I'll just, there's things like, is it maintained? Do code review best practices happen? Does it have a security policy? And things like that. So this is a good place to start understanding your dependencies, but it is only a start. I'm not actually a huge fan, so I'm going to undercut the entire title of this talk. I'm not actually a huge fan of trying to reduce sustainability or security down to a single 7.1 out of 10. And to be clear, I'm not actually trying to pick on OpenSSF here. They're doing the best they can. I actually think this scoreboard's better than most of the others I've seen because it's at least attempting to pull in things that aren't just security. It's trying to look at some sustainability metrics as well. But I do think at most these are just vague heuristics. This is the starting point where it's okay, if something 10 out of 10 health and something's 1 out of 10 health, you probably go look at the 1 out of 10 first, right? Maybe you don't look at the 10 out of 10 at all. But I think the magnitude matters here. Trying to say that there's a meaningful difference between a 7.1 or a 7.2 feels completely useless to me. So I think it's very easy for us in tech to hyperfixate on numbers. I do it all the time. I like baseball. Baseball's got a lot of numbers. Good example. But doing so to the exclusion of other factors is just not going to work. So, assuming we accept that trying to score anything is an imperfect science, I guess what we can think about is what health factors are we actually interested in? So I'm going to talk through the ones I think of. These may not be the same ones you think of. That's okay. So things like how many issues are being opened on a repo, how many pull requests are they getting, how many maintainers are reviewing those pull requests, what's the recent activity level? Because we've all seen repos where there's hundreds of issues being opened on a really popular project, but nobody's reviewing them or triaging them or looking at them because nobody has any time. That's, spoiler alert, that's probably an issue. Commit author diversity is another one too. I don't so much mean diversity necessarily in the DEI sense here, but more just literally how many committers are there? A single person project is obviously going to have some risk factors that a large project with 100 contributors doesn't have, but the same is also true in reverse. A project that hands out commit bits like candy also might pose problems. So you kind of have to be aware of the shape of the project that you're looking at. And yeah, the shapes are different. Some projects might have little recent activity because they're done. I don't think there's too many, we can all think of examples. I probably would have used xkcd as an example, but for what happened last year, there are projects that just don't evolve much because they don't need very much. Some projects might only have one author because they're a singular labour of love and the author doesn't want to collaborate with anyone. So you've kind of got a balance scale, recency, etc. Again, understanding the shape. So I threw some just really basic code to take that SBOM, pull data out of PyPI and GitHub to just annotate the dependencies and just dashboard this. So this is illegible. I'm going to zoom in a second. I, because of my bias, did not present this as a scorecard. Like I said, this is a winnowing function. This is just we're trying to find, instead of 592 packages, we're trying to find okay, what are the 10 maybe that we can actually make a difference on? Again, the 10 that matter to me might not be the 10 that matter to you. They probably won't be, in fact, but that's okay. So I've blurred out the package names just because I don't want anybody brigading any maintainers. Also, just not that important. But this is kind of how I think about some of these things. So this is a dependency that has a significantly lower commit rate recently, hasn't closed an issue in the last month, but has had historically a lot of committers. So that would be one where I'd be wondering is there a lack of review and triage bandwidth here? Is this something where, maybe it's worth reaching out to see if there's some sort of help that can be provided here. Also this repo, and both the repo and the owner accept sponsorship. So it's also, if I'm working at a company that has, maybe potentially a little bit of a budget for this, could we actually help in that way as well? And I'm going to come back to kind of ways you can help in a second. But You kind of get the general gist. Here's an example of a package that's probably fine. It's got lots of commits, lots of committers, doesn't accept sponsorship. Its issues get closed and PRs get either merged or closed very efficiently. It's unsurprisingly by a large company that you've definitely heard of. They handle PRs so efficiently, I'm actually kind of jealous of them. I kind of felt some imposter syndrome when I saw this. We probably don't need to give them help. They're making billions of dollars a year. They're fine. And then, as a final example, here's one that's kind of in between, where it's like they accept sponsorship, they've had a lot of commits recently, but they're also struggling to keep up with issues. So again, it's like, is there something that we could do there to maybe help? Could we write some PRs, potentially, to help fix some bugs? But again, I'm hammering this point, but I just want to reiterate, we're just identifying potential candidates here for support. Once you've kind of got your list, you still have to go figure out the shape of those projects, figure out what they need, see what their documentation says. You probably can't just feed this to an LLM. I'm sorry, it probably involves actual people. Spend an hour reading recent issues and PRs, look at like if there's a chat channel, look at the chat backlog on Discord or whatever, and so on. Because sometimes the need for support doesn't always manifest in these metrics so much. I know, for example, of a Rust project team that's really struggling right now with lack of maintainer time. And yes, we at the Foundation and the Rust project are trying to help with this. But you probably wouldn't know that if you weren't on their very specific chat channel for that team, because everything else looks okay. They're triaging issues, PRs are getting merged. But if you look at their chat, they're completely blocked on like a couple of significant things that they need to implement. So sometimes you just kind of have to dig in there and just see what's going on. Okay, so let's say we've got a short list. What can we do more concretely? So I don't always think the answer is to blindly throw cash at things, but throwing cash at things is really nice if you are at least fortunate enough to have some cash to throw. Or more importantly, I suspect for most people, including myself, can you convince someone else at your place of employment to throw cash at the problem? A lot of developers accept sponsorships, a lot of projects accept sponsorships. I strongly advise if you work for a for-profit company, and particularly if you work for one that's doing okay, find out if there's a budget for supporting open source work. If there's not, ask. I worked at a company several years ago where as soon as somebody raised this as a thing, they were like, oh, of course we'll find a budget for this. This is super important. This is existential to our security story. But because nobody had asked to that point, they'd just never done it. And all of a sudden, some bags of money suddenly became available. So that's important. There are also clearinghouses, Tidelift's one of them, ecosystem foundations, that may provide donation opportunities, although since the point of this talk is actually to find the underserved dependencies in your graph, chances are they have the same blind spots that others do. An option I think is often underused in the corporate world is in-kind donation. Donating 5 or 10% of an IC's time to help with project tasks is actually huge for a lot of projects and maintainers. I'm personally, my biggest problem, well, I have lots of problems, but my biggest technical problem is usually that I'm very time poor. So that's like in-kind help is often what I really want. And project tasks don't just mean writing code. I think probably the most useful thing I've actually done ever in open source was being one of the 2 people who triaged the PHP bug report Firehose for several years. Triage, documentation, community management, code reviews, these are all things an IC can help with. And then they get to know the code base better, so suddenly you know your dependencies better. Sponsoring infrastructure, also an excellent way of helping projects. Open source projects of a certain size often get good support from large infrastructure providers, although this has become a lot wobblier in the last 6 to 12 months. Not that I'm speaking from personal experience, I can't talk about it all. So this is also a useful one, like credits for cloud platforms, for code forgers, for things like that, really important. Can be a real multiplier for maintainers or projects. But the best thing to do is to just ask. Like, figure out what the dynamic of the project is, figure out what the shape is, figure out who needs help. But then really the most useful thing is like, do that terrible thing that we all hate doing and just like write a cold email or a cold chat message and just be like, hey, these are some things we might be able to do. What specifically can we do to help you? Of course, you also need to be in a position to actually listen and to follow through. But if you can do that, that is the most important thing. That is basically what I came here to say. So supply chain sustainability is, I think, super important. I think it's critical, and I think it's on all of us to try and do a better job of it so that we don't have a repeat of the XZ situation. I do intend to share the code that generated that dashboard at some point, but honestly, deps.dev surfaces most of this already. It's not that hard, but if I can spare you the horrors of figuring out GitHub's GraphQL API, I am happy to. Thank you for listening.